Okay, so in this problem we got to find W and Z, which are both sides of a right triangle. So to find W, we don't need to use Soh Cah Toa because it is a special right triangle. I know that because the angles are 30, 60, and 90. So if I just draw this a little bigger, because I write kind of big, alright, this side's 30, so that's W. This angle's 90, so that's the hypotenuse. And then this angle's 60. So we don't need to figure out what the long leg is. We know the short leg is what we got to figure out, and we know the hypotenuse is 150. Well, the ratio between the hypotenuse and the short leg of any special right triangle, 30, 60, 90 triangle, is always going to be 1 to 2, or 2 to 1. So you could figure out that W is just 75. Now, the reason for that, one, is you could just take these ratios and divide by 2, and you get W 75, right? But why does that work? If you imagine another 30, 60, 90 triangle that's identical to it right here, all right, so that's 30, that's 60, all right, this side is 150, just like this side here is 150, all right, well, this angle is 60, this angle is 60, and this whole angle is 60, which means that this whole side should also be 150 because it's an equilateral triangle. All the angles are 60. So this altitude, right, in between the two 30, 60, 90 triangles is going to divide this side in half into 75 and 75. All right, and that's true for any 30, 60, 90 triangle. You can think of it as just a half of an equilateral triangle. So when you split an equilateral triangle, you create two 30, 60, 90 triangles. So that's why that ratio happens. All right. And then if you know that, you could do the Pythagorean theorem to figure out that this side here is 75 root 3. All right, but we don't need that to find Z. All right, to find Z now we need trig, specifically tangent. So we know that this side here is 75, and that side Z is what we're looking for. Now, how do I know to use tangent? Well, it's because I'm given the opposite leg, and I am and I'm looking for the adjacent leg. That's a Z. I thought that was a 2. Soh Cah Toa, if we write that out, we see that, all right, we're looking for the adjacent leg, so maybe cosine, maybe tangent, definitely not sine because it doesn't involve the adjacent leg. And we're given the hypotenuse, we're not given the hypotenuse, so we're not going to use cosine. We are given the opposite leg, so that's why we use tangent. So we do the tangent of 40 degrees is equal to 75 over Z. Alright, now when we type in the tangent of 40 degrees on the calculator, okay, we get 0.8391. Now that means that for every triangle that has a 40, 50, and 90 degree angle, the side opposite the 40 degree angle is going to be about 83% of the length of the side across from the 50 degree angle, which should make sense because 40 and 50 are pretty close, right? These sides are pretty close, but 50 is bigger, so the side across from 50 should be a little bigger. Alright, so then we have to cross multiply, alright, and when you cross multiply, you end up with, you get that Z is equal to 75 over 0.8391, and if you type that in a calculator or just do 75 divided by the tangent of 40, that works too. Alright, you get that side Z should be about 89.4.